And this recording is about word problems that you will see in quiz 4. So this is kind of a review for that quiz in Unit 2. So we're just going to do some examples that pertain to the types of questions they will ask you on that quiz. So first they talk about changing between percentages, decimals, and fractions. So for example, if we had 60% and we want to change that to a decimal, we move the decimal place 2 spaces to the left. So 60%, we move it over, becomes 0.60. And if we want to change that to a fraction, we want to take the decimal part of it and then notice that there's 2 spaces after the decimal point, which indicate that it's in the hundredths place. So we take 60 and put it over 100, and then we have to reduce this. So first we're going to divide top and bottom by 10. We'll get 6/10, and then we're going to divide top and bottom by 2, and that gives us 3/5. So 3/5, 0.60, and 60% are all equivalent. Some other questions that you might get asked, like what number is 38% of 85? So this can be done a couple different ways. One is using ratios, another is using like an equation. So what number is 38%? And anytime we use these types of percentages in a problem, we want to change those to a decimal. So this would be 0.38. So we have x, and we have 0.38, and we have 85, and we need to figure out how we could connect all of these. So what number is? So is usually the typical word for an equal sign. And then the word of, so 38% of 85, we want to multiply there. So you might need your calculator for some of these problems. We want to take 0.38 times 85, and that gives us x equals 32.3. Finding sales price. So what is the sales price of an item that is on sale for 20% off? The regular price of $150. So this problem is done in a couple different steps. First we need to figure out what 20% of 150 is. So we want to take 0.20 times 150. And that gives us 30. So the discount is $30, but we want to know what is the sales price. So that means we have to subtract 150 minus 30, and that gives us 120. So the sales price, what you would pay for this item, would be $120. Another example, temperature dropped from 80 degrees to 60 degrees. What is the percent decrease in the temperature? So we want to know what is the percent decrease, not what percentage this is of the other one, but the decrease. So first we have to figure out what the difference is between the temperatures, 80 minus 60, and then we divide that by what the original temperature was. So we get 20 for the difference, and we want to divide that by what it started out as. And when we divide that, we get, you're going to get a decimal to start. So 20 divided by 80 is 0.25. but they want a percentage, so we just move the decimal place 2 spaces to the right. So we get 25%. So the percent decrease, it decreased by 25%. Another example, the amount of chemical solution measures is 2 liters. What is the percent error of the measurement? So here in the lessons, they talked about that the greatest possible error is half of the unit. So in this case, we're talking about liters. And so we need to know what's half of 1 liter, because that's the unit. So it's half of the unit. So 1/2 of 1 liter would give us half a liter, or 0.5 liter. And then to find the percent error, we take that number divided by how many liters we have. So 0.5 divided by 2, and that gives us 0.25, or 25%. So there's a 25% chance of error when using liters as measurements. Another example, an account earns $460 interest in 1 year at 7%. What was the amount of money invested? So this deals with simple interest. The formula you use is I equals PRT. I stands for interest. P is the principal, or the money that you start out with, or money you invest. R is the rate, and that's a percentage, but we use it as a decimal when we go to figure out problems. And T is time in years. So we know that there was $460 interest. P is what we're trying to find. Our rate is 0.07, because 7% as a decimal, and then times 1 year. So looking at this, it just becomes a problem for an equation we can solve. And so to get P by itself, we need to divide both sides by 0.07. And so 460 divided by 0.07 gives us $6,571.43 if we round up. Another type of problem, a certain bleach has 6% of active ingredients. So this is looking at the back of the bleach bottle. It'll tell you like all the ingredients, that it says some are active and some are inactive. So this one's 6% active ingredients. In 10 gallons of this bleach, how much is active ingredients? So when it says 6% active ingredients, that's per gallon. And so if we have 10 gallons of it, then we need to change the 6% to 0.06, multiply that by 10, and that will tell us how much of the 10 gallons is active ingredients. So 0.06 times 10 gives us 0.6 gallons. Another problem, chocolates costing $8 per pound are to be mixed with chocolates costing $3 per pound to make 20-pound mixture. If the mixture is to sell for $5 per pound, how many pounds of each chocolate should be used? So in this case, a chart tends to be a little bit easier to keep track of everything. So we're looking at three things: the pounds of chocolate, the cost per pound, and then the total cost. So it says chocolate's costing $8 per pound. So we know it costs $8 per pound. And then it says it's mixed with chocolates costing $3 per pound. If the mixture is to sell for $5 per pound, and we want to make a 20-pound mixture, how many pounds of each chocolate should be used? So in this case, the bottom row is going to be the mixture, what we're trying to find. So it told us that we have some chocolates that are $8 per pound, but we don't know how many pounds, so we're going to call that X. Now the other thing is that we know that we want a total of 20 pounds. So the $3 per pound chocolates cannot be more than 20 pounds. So in this case, this one is 20 minus X. It's the difference between the two. Now in these charts, we multiply going across. So if we have so many pounds and $8 per pound, then the total cost is those two multiplied. Same thing here, 3 times 20 minus X. And then 20 times 5 is 100. So where does our equation come in? And that is from this final column here. And so we add 8x plus 3 times 20 minus x equals 100. And we want to solve this equation. I'm going to rewrite it here so we have more room. So we have to distribute the 3 first. So we have 8x, 3 times 20 is 60, 3 times x is 3x equals 100. Then we want to combine like terms, so 8x minus 3x is 5x. And now we can continue to solve. So we want to subtract 60 from both sides. And we get 5x equals 40. And last but not least, divide by 5. And we get x equals 8 pounds. So x is the one that costs $8 per pound. So then we know that 20 minus x is the other one. So the other one is 20 minus 8. So 22 pounds for the other type of chocolate. Alright, last example. How much pure water mixed with 10 liters of a 20% acid solution is needed to reduce to an 8% acid solution? So they're talking about whatever thing they have has 20% acid in it, or 8% acid. It has some acid in there. But it says pure water. So the key to this one is that I'm adding pure water, which means that it has 0% acid in it. So we could draw a chart again on this one if that helps. And so here is the liters of the mixture. So meaning that we have whatever mixed with acid. This is the rate, so the percentage of acid. And then these are also liters, but it's of the pure acid. We want to know how many liters are just acid. So it says how much pure water. So we don't know how much, but the rate is 0 because it has 0% acid. And we want to mix it with 10 liters of a 20%, so 0.20 solution to reduce to an 8% solution, so 0.08. And then to know how many liters we're getting, we know that this mixture here has to be x plus 10. Again, we multiply across, so x times 0 is 0. And we have 10 times 0.2, and that gives us 2. So if we look at that, they have a 10-liter mixture. It's 20% acid. And so what that means is 2 of those liters is pure acid. The rest is other stuff. And then multiply across here. 0.08 times x plus 10. And again, our equation is coming from that last column here. So we have 0 plus 2 equals the bottom. Okay, 0 plus 2 equals the 0.08 times x plus 10. Well, 0 plus 2 is 2. Then we have to distribute the 0.08. So 2 equals 0.08x plus, and then 10 times 0.08 is 0.8. Then we have to subtract 0.8 from 2, and we get 1.2. And then we have to divide by 0.08. So 1.2 divided by 0.08 gives us 0.96 liters. So we need 0.96 liters of pure water to dilute that mixture to an 8% acid solution. Okay, so now that you've watched this recording, you need to call, text, or Skype message me so I can ask you a couple questions and you can get credit for this assignment. Have a great day.